Once again, I have the last slot, so I can extend it. No. So, welcome in Kotlin Not-to-Do List, the only presentation when we will be talking about things that we should avoid doing in Kotlin. This is based on my book, Effective Kotlin, I just published, and it has many items about things that we should do, but there are some items that are, no, this is not the way. And this is what this presentation is all about. I divided this content into three main categories, three big sins of Kotlin developers. And the first one is hiding too much. And I actually think that the problems goes deeper. It's not only hiding too much, it's a whole culture of hiding things that are growing in Kotlin. Just imagine that you are hurried to the job and you are looking for your things, telephone and keys, but then you remind yourself that in your family there is a growing culture of hiding things. And this is how I sometimes feel in Kotlin, and let's see what do we hide. And let's start with what we all love, type inference. So it's clear that this is a number, so it's perfect, we don't need to state it. It's clear it's a string, it's clear it's a list of integers. But what if it is not clear what is that? So in such a case, type is an important information for a developer and might be really useful. So my suggestion is to state the type where it's not clear. But type is also an important information for compiler in some cases. And to understand it, let's first think about the case where we set a subtype of some type and then we are trying to set supertype. You know it's impossible when you use type inference because type inference is exact. And clearly the solution is to set up the type. But not always you can apply that solution. So think about the following case. You make a library that is dedicated to produce cars. And since you have one particular car that you produce in most cases, let's say Maluch, you decide to make it the default one. But then you say, hey, it can be inferred, let's just skip it. Sometime later, someone thinks, oh, in default car it can be inferred, let's just skip it. And congratulations. Now you can only produce this particular model of the car. This is exactly what happened here in Poland 30 years ago. Type can be important for compiler, and it's an important information, especially in public APIs. I'm sick of trying to find out what is returned by some function from library and going up and up and up and up and up, and some generics and transformations on the way, and sometimes I even compile it to see what is stated there. When you write library and you expose type, state it. Another problem is null safety. As we know, Kotlin has a great null safety system that protects us from nulls. But what if it does not? It does not when we are interoperating with Java. As we might know, when you have these annotations specified, we trust that they are right, and we are typing as either nullable or not null. But what when we do not state that? Well, we do not like this situation, and the first change that all libraries do to support Kotlin is introducing all those labels because they are all supported to make Kotlin a better place. But still, we might meet some types that are not annotated. And what do we have then? It is called platform type. It's a type that still can be typed as nullable or not null. So it's like a Schrödinger type. It's not yet specified. And in this example, if getUser returns null, we will have an error in here. But believe me, this is the worst case. Why is that? In the first case, we are stating the type. And if we are wrong, we will have no pointer exception in here. It's clear where does it comes from, what happened, how to fix it. When you do the same, but without specifying type, we will also have no pointer exception if you use it unsafely. But who knows where? It might be used safely sometime, and then unsafely. Maybe developer remembered it's knowable and used it safely, and then another developer came and used it unsafely. It's like with platform type, we are back in Java. And we do not know where null will blow, and we don't know what will happen. So we are stating this type as soon as possible. We are eliminating platform types as soon as possible. Platform types also very badly interoperate with our typing system. Imagine what happens if we infer them further. So it's an extreme situation when we infer platform type into a type returned from a function in an interface. So this is a platform type. It's still unspecified. I can still decide if it's knowable or not. So in the declaration side, I can say, hey, it's knowable, and I return no. In the use side, I can decide it's not knowable and use it unsafely. Now we have null produced in Kotlin and null pointer exception blown in Kotlin. So again, with platform types, we are back in Java. To be fair with Kotlin, we have a good warning stopping us from doing that. But, well, I still see that, so it's better to remember to not have inferred platform types. Another thing that we are hiding too much is the receiver. So again, something we love. If we are referencing an object again and again and again, it's much easier to just use apply and reference it implicitly. So here there is this that is used implicitly. And this is great because it's absolutely clear what is this, but it's not always so. So my first recommendation is when you are writing extension functions, you can still use functions implicitly like first or drop, but then it might be confusing where they come from. Are they top-level functions? Maybe they are from somewhere else. So it's, in my opinion, much better to specify the receiver explicitly. What is even bigger problem is when you are just juggling with these receivers and having receiver inside receiver. And you need to notice that when you do not have something in the current receiver, we are implicitly looking to the outer receiver. If you use receivers implicitly, you are looking in the outer receiver. And here is a very small puzzler. So here we are creating a child, and create returns a node. And so when you call apply and you try to print its name, you might expect that you will print the child name. But if you run it, you will see it actually prints a parent name. So what went wrong in here? What went wrong, you can discover if you use receiver explicitly. So if you state this, and if you do that, you will see that you cannot use it because this receiver is nullable. Here, node is nullable, so in apply, node is nullable. So this is why we couldn't use name from the child. So we looked further and we found a name in the parent. No warning, just all that happened implicitly. Clearly, one solution is to use a safe call, but much better general idea is that when it's not clear what is the receiver, and also when we do not really need this receiver, it's better to not introduce it at all. It's better to use function like also or let that force you to use argument instead of receiver. So instead of this, you need to use it or an argument. So it's always explicit. Does it make sense? Great. And one last suggestion is to avoid member extensions. So it's possible to have extension function inside a class, but it generally does not make sense, and it's really confusing. It cannot be referenced. It's much better to make it a top-level function. Oh, people do that to limit its visibility unsuccessfully because it can still be used in a weird way. It cannot be referenced, and a much better way to do that is to lift it into an extension, into top-level extension function, and then it can be referenced, and also it's much more clear, and we limit visibility by using visibility modifiers. Member extension functions are confusing in many ways. So when you are referencing some property, it's not clear where does it come from. Does it come from A or does it come from B? It's not clear for all the users. When you're supposed to modify something, what do you suppose to modify? Do you suppose to modify A or do you suppose to modify B? Again, very discussive. So it's better to avoid it. Another big sin of Kotlin developers is choosing short over readable. There is a common misconception that Kotlin is made to be concise. It is not. There are much more concise languages, like Scala, for instance. But there are even more concise languages, like, for instance, APL. This is game of life implemented in APL. One line, perfect. Your first thought is probably, whoa, that's short. Another one is, I don't have half of those characters in my keyboard. There are more such languages. There is J that is also of similar length. I couldn't implement game of life in Kotlin in less than 10 lines, but it was readable. Those are champions in programming golf contests, but those are not really readable language. And the general concept with Kotlin is that we are striving to make our projects readable, not necessarily concise. And this distinction can be well seen on those two snippets. So I started from asking quite a number of Kotlin developers, which one do they think is better? And I was surprised how many experienced Kotlin developers told me that they would prefer the other one. But when you think about it deeply, except of the advantage that you can show how well you know advanced Kotlin features, there are no real advantages of using the second implementation. So the first one is clear. You just see it and you understand it. No matter where do you come from. Are you Kotlin developer? Are you Scala developer, Java developer? It's clear for everyone, even for JavaScript developers. The second one is clear for none of those, including most Kotlin developers. To understand it, you need to understand safe call, take if, let, bounded function reference, Elvis operator, and with this weird use of expression that is a function call on the right side. It is harder to debug, harder to understand, and harder to extend. Imagine that you need to add something to each of those lines. In the first one, pretty straightforward. In the second one, you need to refactor it. So in the first case, you cannot use function reference. You need to use a lambda expression. In the second case, you need to wrap it into something to be able to have more than one call, what makes it all even more weird and hard. And the funny thing is that the second one is not really so much shorter. And I think it's like 6 or 7 characters difference. So the saying that the second one is better because it's shorter is not really true. And finally, when you are using strange connections of language-specific features, it's very hard to really understand what is going on. Who noticed that those two do not do the same thing? Okay, I think you know this example. Someone who does not know this example? So tell me. No, because in here we have a safe call as well, so we will not check if it is adult, if this is null. But when is the second one showing an error? Because in the first one it's clear. When it's a null, when person is null, or is he or she is not adult. But when is the second one showing an error? Not adult, or when showPerson returns null. It is possible. Yeah? showPerson might return null. So in some languages, they are using this mechanism to indicate, say, an error or lack of errors. So it is very hard to find it, and good luck finding it if you have such an error on your real code. So in my opinion, using basic features is generally better, and using advanced features just to use advanced feature is no way to go. It is also connected with this item, which is connected to a job interview of my friend, who was asked in London, why would we need to return unit nullable? What sounds like a strange question, but let's think about it. So it turned out, I mean, if you think about it, unit nullable has two values, unit or null. So it's like Boolean, two possible values, and so they can be always used interchangeably. But well, if you use unit nullable, you can use all the cool features like Elvis operator. This is, of course, a terrible use of unit nullable, and we have Boolean to use Boolean, and I suggest to use it instead and do not operate on unit nullable. For me, it's a terrible smell of code. Another example comes from my workshop. So we already did a factorial, which was already implemented today on another presentation. And later, when we implemented it as an extension function, so it can be called in this comfortable way. But those who finished school know that factorial is in mathematics noted as exclamation mark. And later, when we talked about operator overloading, one person noticed that, well, actually, we can have a similar notation, only exclamation mark before a number, if we make an extension function on integer with operator not. Well, as the name suggests, this is not how we should use this operator. And you can always use it as a function instead. And my general rule is that our operator should be always consistent with its name. So every operator in Kotlin has a very concrete name, and this very concrete name has a very concrete interpretation, mathematical in most cases interpretation. And the connection should be very clear. The contract should be always kept. And remember that always operator can be used as a function instead. It does not apply only to DSLs, which are different word. There are sometimes unclear cases. So imagine that one person says, hey, I want to make int times function operator, because it's pretty clear that int times function means producing a function that repeats the previous one 3 times. But then someone else comes and, no, for me 3 times mean invoking a function, this function 3 times. And so this is pretty clearly unclear case. And I suggest to not use operators when the meaning is not absolutely clear, because then they are only confusing, and they can lead to terrible misunderstandings in the code. So it's better to use infix functions like 3 times repeated, and repeat is already in the standard library. So another sin of Kotlin developers is disrespecting contract. And I very like this notion of contract. I spent half a chapter on that, and I believe it's very important concept in programming, and we should think about it more often than we do. But to get there, I think the easiest way is to think about visibility modifiers. So you should be familiar with the concept that in Java, it's better to limit visibility of the functions. There are very good and properties. There are very good reasons for that. So in general, everything that is visible is a part of API. And we prefer to keep API as small as possible because API needs to be tested, maintained, documented, etc., etc. It needs to be handled well, and if we change something in the public API, our users might be really angry because they need to adjust in their own libraries. It's also easier to expose something later than to get something people are using. It is also about the state. So when, especially about properties, we especially limit visibility of properties, read-write properties, because they represent state, and class cannot be responsible for its own state when it can be modified from outside. So here, it's this property represents previously downloaded users, but if it would be public, then it might represent anything, pref user set from some outer place. So we cannot guarantee state if we do not control it. And also, it's easier to track it, so it's about debugging and understanding classes. When visibility is limited, we know when it can be changed, and we are sure it won't be used in some weird ways by users when, for instance, we are tracking some problem. But it needs to be understood that by setting visibility, we primarily communicate our intention with user that we don't want it to be used. It's not that user cannot use it. He can still use it if he really wants. Imagine this simple class with a function, and if user wants to use it, all he needs to do is to sit down and reflect for a moment and reference this class, find member functions, find one by name, open it, and he can call it however he wants, he or she. If you think this is too hard for users to do that, I can just make extension function. People will not do that because they cannot. People will not do that because by setting it to private, we are setting our intention that we do not want them to use this. And so users will know that when they are using it anyway, it's on their own responsibility. So if they have some errors then, or if their code stop working because, let's say, you change private function name, it's their problem, not yours. It's like with a warranty. If you open your computer and start changing something inside, it will not be accepted under warranty. And visibility modifiers are part of the contract, but a very important part is a documentation. And in Kotlin, we primarily specify documentation using KDoc. It's, of course, KDoc is much more extended, but it's a very simple example. Those are those special annotations before functions and classes with some special elements that can be used later to generate documentation. And from one side, by specifying documentation, we are specifying our intentions as owners. On the other side, as users, we read those documentations to know what can we expect from creators. And when you look at standard library, Kotlin standard library, for me, it's one of the best contract I've seen because it's very, very minimalistic, like nearly everywhere. So if you take a look at any function from standard library, you will see some essential sentences describing this function. Like in here, returns a new read-only list of a given elements. The returned list is serializable on JVM. That's all that is promised. It's also promised that it's of type list of T, and that's pretty all. That's exactly what is promised and nothing more, nothing less. So if you try to hack it by using some internal knowledge, like let's say you try to upcast list into a mutable list, you are breaking this contract because you are using some knowledge that is not promised to you in any way, and you do not know how it will behave. So in Kotlin.js, it will actually work fine. In Kotlin JVM, it will throw unsupported operation exception now, but with persistent list in the future, maybe it will not work at all. Like, who knows? This is the freedom that Kotlin creators give to themselves. And we should respect it and use what is allowed by the contract. And actually, there is a lot allowed. So for instance, we can use two-mutable list, that is an extension function on a list, so something that is totally consistent with the contract. Three functions that have very, very well-established contract are functions from from any in Kotlin. And especially important two are equals and hashCode. We do not have time to describe it all, but I would like to just tell you that when you implement it yourself, think about it and check it. And I have, of course, whole item about equals and whole item about hashCode, and showing all the different ways how it can be broken. And this is one example. So here we implement equals of a complex number. Complex number is having real part and imaginary part, and we can make equals. Like we can compare equals to a double. They are equal if this complex number have imaginary number equal to 0 and real number equal to this double number. Or it can be compared to complex. So what is wrong in this implementation? It is not symmetric. What it means is that we made complex equal to double, but we cannot make double equal to complex. So what? And so we cannot trust anything that uses complex. Imagine that you have a list with complex, and then you call contains with double. And so what do you expect it to return? True or false? Well, I don't know. Under the hood, it might compare one to another or another to the first one. I don't know. Or maybe later, maybe it will now return true, and after some time, it will change internally and return false. Who knows? One collection will say yes, one collection will say no. So we cannot trust at all contains, set, assert equals, anything that uses equals under the hood. We just do not know how it will behave, and we cannot be sure that it won't change over time. So similarly with hashCode, and another code example, a very simple one. So what is wrong in here? It's the most obvious one. Yeah, there is no hashCode, but there is equals. So hashCode by default is based on the address, and equals is not based on the address. So you have two equal number, but if you use some collection that uses hashSet under the hood, like set, and you have one of them, and you check it if contains the other one, it says no, even though it should say yes, because they landed in a different bucket. So some people have an idea that the easiest solution is to just return constant. And we have a warning in Kotlin. Some people have idea that the easiest way is to return constant. And I wanted to show how terrible this solution is. So imagine that you have correctly implemented name, some wrapper over value, and incorrectly implemented that returns constant. And then you make quite some elements of this type. Let's say 10,000. If you use the correct one, equals is used exactly 0 times. And it turned out that every single one landed in a different bucket. So we do not need to use equal at all. In the second one, equals is used 50,160,683 times. So this is a big number. Also, when you are using contains, you are having different numbers. So with correctly implemented instance, you are having equals 1 and 0 times. In incorrectly, thousands of times. So it can all be gone if you just implement hashset correctly. Okay, we are talking too much about contracts. I just want to add that Kotlin functionalities also have their own contracts, if you think about it. So what do you think is wrong with this snippet of code? What's your first idea? What just feels bad over there? Yes, it's a sealed class, but it works fine. But what is wrong when you, what do you feel is wrong when you take a look at that? Well, value is a property of Leaf, but the problem is why the hell this sum is an extension property? It's an algorithm. It pretty surely should be a function. So extension properties are used to represent state. Should have a O1 complexity, should be simple, should not have business logic, should not contain algorithms. Those are all for functions. And on the other side of the barricade, properties are used to represent state, and so we should not use functions the way we use properties. So there is also distinction between those two. There are contracts with Kotlin features, properties, and functions. And the final item, final bit of knowledge is the suggestion to avoid function types, to avoid single abstract methods, to prefer function types. So some people having habits after Java prefer to use interfaces with some methods to represent listeners on some other holders of behavior, but the Kotlin way is to use functions. Notice that to make a listener in the old way, you need to create an object or object expression. In here, you can use lambda expression, anonymous function, function reference, bounded function reference. You can even make a class and make an instance if you really want, because function types are interfaces under the hood. And those are three big sins of Kotlin developers. We are hiding too much. We are too often choosing short over readable. We are too often disrespecting contracts. And we need to strive to get better, to make visible what is the important information, to always choose readable, and to understand and respect contracts. For the reference, those are items that I used. Book is published on LinPub. It can be found online, but it's not yet on paper. I also know it will be translated into Polish because Pewien contacted me, but it will probably take some time. And that's everything from my side. Slides will be, as always, on my Twitter. And thank you for being a great audience.
Thank you very much. So we do have two questions on the Slido. If you could show it, that would be great. So yeah, the first one is, can platform times be considered a bad design? Wouldn't it be better if all unannotated data coming from Java be nullable?
Well, so it used to be that way, and we ended up, it's also described in the book, it used to be that way, and we ended up with a lot of not null assertions, and generics were not working fine. So there was a lot about reactive programming in here. So imagine that you have observable with a string, and then you have a nullable observable, which nearly never happens, with nullable string, which is also unlikely and in most libraries illegal. So that's the primary reason why we have platform types, but we just should eliminate them as soon as possible. And some things. Who is Android developer in here? Android developers? Okay, so I do not have Android Studio open right now, but you will probably use Kotlin Android extensions, and so if you use it to get a a view, what you get is actually a platform type, because in most cases it is there, but in some cases it might not be there. For instance, if you have it on one, let's say, horizontal view and not on vertical. Okay. Should custom contracts be used in application code? Okay, I will check it. So, okay, you just mean the Kotlin contracts. Well, yes, but I think you would need them rarely, as they are the two ones, the two contracts that are introduced right now are primarily for util functions. So maybe implies might be used sometimes, but I haven't yet needed that. So yeah, why not? But I think it's rare. How do you decide when to use let also apply, blah, blah, blah. So I know there are many opinions, so I will open something. Okay, I even have something. This is a nice example, by the way, but maybe another way. So for me, apply is when you initialize something and you just want to set it up. Also is all the additional operations. Run and with I use practically never. I see pretty often people use them instead of the way how I use apply. And let has 3 primary use cases. I will just create a new one. So, as you know, let is like a map for a single element. And so the first case is that when you have I do not have a presentation, but when you have something, when you have the decorator pattern, which is not uncommon in Kotlin, that generally looks like that. You can imagine, for instance, a stream. So you have a file reading stream, then you have unzipping stream, and then you have, let's say, buffering stream, etc., etc. So instead of that, it's much easier to just use .let and like make a similar processing as for map, but for objects. Another case is also pretty known. So if we have a, let's say, class user with name, and if you want to, let's say, print name, var user. So in general, if it would be a different case, what we would do is checking if user is not null, we are printing username. But we cannot do that because it's a property var, so it could be changed by another thread in here. So a very popular idiom is to, one way to fix it is to shadow it. But now you cannot use easily outer user. And so a popular idiom is to just use let with safe call. Of course, we could use apply, but by conventions, people started using let, so we still use let for that. Well, probably yes, but conceptually yes, but since I think people always used let, I would treat it rather as a Kotlin convention that we generally use let, probably because also was introduced in Kotlin 1.1. And the third typical case of that you can find of let is it's perfectly seen in here. So let's say that you have something pretty long, like a collection processing or some other long processing, and instead of wrapping it into print, what is first of all does not look good, and second of all, is it big enough? Okay. First of all, it's not. It's also disturbing because you are first calculating inside and then you are printing it. So it's, I believe, much more cleaner if you just do the processing and on the end you do .let print or .let print it. What is the way to like lift this operation on the end of the processing without necessity to introduce another variable. I think the same. I mean, it could be. I hear the voices of Scala community. We should probably. Yeah. Sorry. So yeah, of course, apply is not a good choice for here. Also, it sounds good, and yes, some people do that. I think people more often use let, probably also for the same reason, because it was before, and it's yes, but for the same reason, probably let is better because let is returning unit, so you cannot do anything more. So it's like terminal operation. I don't know. It's a very opinionated. Should I ever write an extension function for class that I control? Yeah, why not? There is a whole item about it. It's a pretty long story, but there are differences, and if a function is not a core part of a class, but rather something extra, it's a very suitable for an extension function. And also, if you take a look at what is done by Kotlin team, you can find that they control everything inside there, but most things are extension functions for good reasons. Extension functions give us more possibilities. They are on type. They need to be imported. They are easily controlled, etc., etc. So sometimes yes, whole item about it. How to implement hashCode in name-surname case when they both mutable? The easiest way, of course, the easiest way is to use objects.hash, and then you can pass name and surname. But what it does under the hood is calculating name times 31 plus name.hash code times 31 plus surname.hash, something like that. And if we have more properties, we are wrapping more and more and multiplying everything by 31. How would you handle if with null example when property with null would be placed in another module? If with null. So you mean smart casting? Is there a person here? Yeah, so well, it depends, but actually what I showed, this one using save call let or save call also, is a very popular idiom. And I do not want you, it was also better clarified in the book, but I do not want you to think that I'm saying you should not use take, if, let, and Elvis operator. No, those are great idioms, and they are having a lot of sense in cases where they are making a lot of sense. In here, they do not. So they should be used, first of all, they should be used appropriately to the situation. And second of all, we need to remember that every custom feature not known in other languages is introducing a little bit of complexity. What is not a problem when it's like solitude. But it's a problem when you are using all of them in connection together, because, then the complexity like multiplies and everything. You need to grasp it all at once in your head, what is very, very hard. And is it, oh, according to lambdas versus interface. What about combining type alias with lambdas in public APIs? Type alias with lambdas. So I rather think about combining type alias with normal functions, what is also with normal function types, what is a popular idiom, especially if you want to, I don't know, listener, if you have a complex function types. So let's say that you have something like that. What is that? I don't know, and it's not clear to the users. So then it's not suggested, like view and I, and that does not. That's a number. So it's much better to, if we want to add names, what is generally a good practice, at this, like let's say child, parent, and ID. Then we have these suggestions, proper suggestions, and also we make it more clear. But right now it's huge, so a good practice is to make type alias. It should be probably named better according to what kind of listener is that. And this is a proper example of substitution of single abstract methods, because it has name and parameters has name, and so it provides us everything that simple abstract method has. But you know, we need this type alias because otherwise it would be just too complicated to use this huge type every type we needed. But how about using lambdas? Yeah. So is it the answer to the question? Okay, perfect. So I think that's it. I'm not holding you anymore. So
So thank you.
Thank you.
Please give another round of applause.